Hello everyone, welcome back. So let's try out this example right here. What we see is a cart and its load have a total mass of 100 kilograms and a center mass at G right here. A force of 100 newtons is applied to the handle and we're supposed to neglect the mass of the wheels. What do we want to find? We want to find the normal reactions at each of the two wheels at A and B. So right here and right here. Now, I'm going to do this one with you, but the next few you're going to try on your own. So what's our plan? Well, simply follow the procedure for analysis. I gave you a plan, you should use it. And sadly, it does not look like that line is going to go straight through point G. I wish it did though. So first thing we do is make a free body diagram. We show all the forces that are going to be acting on this. The force we're applying, the weight, our normal forces, and then we give the sense and direction. We're saying that's going to be probably going to the right. With that, we can set up our equations of motion. So we do that in the x direction, and what we see is there are no other forces in the x direction. There's only this component that's going in the x direction. So there's no unknowns in the x direction. I can instantly solve and say, okay, I'm accelerating to the right at 0.8 meters per second squared. But what about this normal force B and normal force A at those wheels? Well, if I do my sum of the forces in the y direction, which honestly I feel like is the wrong thing to do right now, because think about it, you take some moments and you could have gotten rid of one of those already, but they're allowed to make mistakes, okay? They can do what they want. So what we're going to do then is we're going to take the sum of the force in the y direction. We see, okay, well, my normal force at A and B has to be equal to my downward force plus the y component of me pushing on the handle. And then if I take some moments around the center of gravity, well, my weight is not going to actually cause any moment around that point, so I don't have to include it. I just have to include the force from my pushing on it, both components, remember there's two components to that, as well as the normal force A and normal force B. Be very, very careful because this is a diagonal force, and that's why there are two components in your moment equation from that diagonal force. So the force y times the distance in the x. The force x times the distance in the y. And when you do that, you have two equations, two unknowns, and you can solve. And you get the normal force at A is 430 newtons, and the normal force at B is 611 newtons. Once again, I probably would have taken the normal force around point B, just because it would probably make things easier to calculate. Maybe not, but that's how it felt to me. Okay, so I believe that's everything. Yes, it is. So thank you for listening, and I'll see you all next time. Have a wonderful day. Bye-bye.